Hello everybody, and welcome to the descriptive statistics portion using SPSS. Today we're going to do a couple things. Primarily we're going to look at frequencies, go over descriptive statistics, and the explore function in SPSS. Now, the first thing that I got to mention is I'm doing this on a Mac. So some of the things might look a little different, but the way you will do all of these is the same. The commands are the same. So for example, the first thing we're going to do is analyze in descriptive statistics. It's the same way on a Mac as it is on a PC. Now, the second thing is we're going to be using the course data set that we used from the first lecture. Go ahead and load that just as you did before. This is just kind of the first quiz to make sure that you know where you're going so far and you have the information from the first one down. And just as I said on the previous lecture, you'll always want to check and make sure your data look right when you open it. So look over here, there's no extra variables that are looking weird. The data all seem to be relatively regular in how it looks. And especially because we've used it before, we're pretty sure that it's going to be okay. So the first thing I said we're going to do are frequencies. And this is one case where you're going to want to look at the PowerPoint I'm providing you along with this lecture. So in the PowerPoint, it has a list of or some notation about the types of variables that you will use in each of the cases today that we're going to be looking at in both the descriptive statistics and frequencies. When we're doing frequencies, it tells us how often things occur. So that can only be used with what are called nominal variables. You might also hear them called categorical or grouping variables. And those are variables for which the numbers are arbitrary. So they're groups. So for example, in here we have, are you a purple, a green, or a gold? Or are you male or female? What is your political affiliation? In all of these cases, your number indicates the group you are in. Those are nominal variables. On the other hand, there are also continuous variables. And continuous variables are where variables are on some kind of continuum from low to high, generally where the order matters. So for example, in happiness, 1 to 5, well, 1 has to be a 1. We know that 1 is meaningful. You're not at all happy. 5, it's got to be a 5. 5 means you're very happy. There'd be no reason to move those numbers around, meaning a 5 you change to a 2 and a 4 is a 1. That just doesn't make sense. With nominal variables, you can change those numbers. So a 0 being for golds, well, that doesn't really matter. Golds could be 2 or 1. Purples could be 1s or 3. The numbers don't matter. So for variables where numbers don't matter, you can do frequencies. So you'll do that by going to Analyze, Descriptive Statistics, and Frequencies. Go ahead and click that, and a box will pop up. And this box is similar to basically all of the boxes we're going to see in SPSS throughout the semester. In it, you have your list of variables in this left box. In this right box, you will put whatever variables are you want to run your statistics on. So in this case, with frequencies, we're going to use nominal variables here. So for example, purple, green, or gold, what are you? Well, let's go ahead and put that over into the variables, and just for the sake of argument, just go ahead and hit OK. And up will come your statistics viewer. And you can see it very nicely, has frequencies, it'll tell you where the data set came from, then it gives you this overall statistics to tell you how many variables are missing and how many you're using. And generally, and especially in this course, this box will not matter, but it's good to know if you ever have a data set that has a lot of missing values in it. Then we have our important table, and that is the frequency. It has both the frequency in terms of the count, the number of the times we've seen these variables, the percent that counted, the valid percent, which takes into account something we don't need to worry about right now, and then the cumulative percent, which is just the first one plus the second one plus the third plus the fourth, depending on where it is. So you can see 42.3 plus 31.4 is 73.7. 73.7 plus 26.2 is 99.9. That plus 0.1 is 100. So you get up to 100%. All right, now you might be noticing in here that there is one person who is a 3. Why did this happen? Well, this is what happens when people don't enter data correctly. So somebody, in the course of putting this data set together, put a 3 instead of a 0, a 1, or a 2. And in that case, you'll just have to decide for yourself how you want to deal with that. Generally speaking, you would go back and try to determine where the error was made, look at the original data, meaning the sheet that people filled out. But in our case, we don't have that. So we're largely going to be ignoring those cases. Might even just delete them outright. That's it for the frequency at the basic level. Now, if we go back to analyze descriptive statistics and frequencies again, we can see that there are multiple other options that we didn't check yet. So let's go in there. To statistics, you can get a lot of values, quartiles, etc. You can get measures of central tendency, which we don't need for nominal variables. Skew and kurtosis, two things if you take inferential statistics we'll talk about more. We're not going to get into there. And more on dispersion as well, but we don't need to worry about that right now. You can also make charts. So we can make a pie chart based on our frequencies. So we can do that, hit OK, and then let's just hit OK again. And you'll see the same information is going to pop up. Nothing has changed, but you get yourself a pie chart that kind of visually represents how many people we have in here. Okay, now in addition to what we've done so far, you can run frequencies from any number of variables at the same time. So you can do it for purple and gold and gender and political affiliation. And if you leave all of the settings as before, we'll get our pie charts again. So if you hit OK, up will pop now 3 separate tables, one for each of the variables. Now this is one thing that's different for frequencies than for descriptive statistics we're going to do later. But we have our purple, green, and gold table here. We have our male and female table here, and political affiliation here. You can see again in political affiliation, there's somebody put a 3. You interpret these the same way as before, so there's not a whole lot of complication here. Now, down further, you will see our pie charts, and it's pretty good. That's about all that you're going to need to know for frequencies. Okay, so now let's move on to descriptive statistics, and you can see the contrast here. So descriptive statistics are in analyze, descriptive statistics, and descriptives. Now in descriptive statistics, you only want to use continuous variables. So any of the ones that we just used, we don't want to use. And I'll show you examples of what goes wrong if you were to mess up. But for now, we're going to do it the right way. So let's say we want to get our descriptive statistics for happiness and how much you like the university. Just hit OK, and we can see our descriptive statistics chart pops up. And for happiness and how much you like the university, we have all of the information for this variable along the first row, this variable along the second row. So we had 1,629 people have a minimum and maximum value. We have our mean and standard deviation, just like you would get if you calculated this by hand. Now, I would not suggest checking this by hand. It might take you a little while to do standard deviation for 1,600 people. We can also see a couple weird things here. We see there's one more person reported this variable than this one, so just somebody left it out. We can also see that the minimum and maximum for happiness is 1 to 5, but for how much you like the university is 0 to 6, which again is weird because it's a 1 to 5 scale. So again, data integrity is important. When you're collecting data, you need to make sure that you are getting numbers that make sense for the scales you're using. Otherwise, this can happen. Okay, now just like with frequencies, we can go back, analyze descriptive statistics and descriptives, and we can go into options and see what else we can do. Well, if you want to get variance and range, you can get skew and kurtosis. You can see, change the order that the variables are displayed in if you would like. For now, let's just add variance and range. And then go ahead and hit OK again. In this case, our table gets longer, and it just adds in the range, which is just the high minus the low. We could have done that fairly easily, but if you wanted it, there you go. And then variance, which you all have are going to be able to calculate with much ease, and hopefully you should know the relationship between variance and standard deviation. Now, again, we can add as few or as many to this as we like. So let's add our third continuous variable in. And as you probably picked up from the first example up here, instead of multiple different tables, like with frequencies, in descriptives, they all come in one table. All right, now let me show you what goes wrong if you add in continuous or nominal variables when you should not do that. And for now, we're just going to stick with descriptive statistics. So if you do descriptive statistics and you add in a variable that you should not, a nominal variable in this case, let's do purples and golds, and then you hit OK, well, it'll look like it works. But when you think about it, this value or these values actually don't make any sense. Now, remember, 0.84 is a mean. Well, is that actually meaningful if the numbers you have used don't matter? Remember, nominal variables, the numbers don't matter. In this case, purples are zeros, golds are ones, and greens are 2. But just as easily, greens could be 1s, golds could be 0, purples could be 2. It does not matter. There's no inherent value to that. In fact, if you really wanted to be obnoxious, purple could be negative 7,000, gold could be 0.1, and greens could be 4 billion. It doesn't matter for how we are going to be doing the statistics. And that means that the values you get in this chart are not meaningful. If you make a descriptive statistics table and include nominal values, you are wrong, even though it might look like it works. So you have to know the difference between nominal and continuous variables. Now, on the other hand, if you were to do frequencies and add in a continuous variable, hit OK. It's not quite as wrong because the numbers actually matter, but it doesn't give us anything we care about. Generally, with continuous variables, we want to know means and standard deviations. Does it really mean a whole lot that we have 143 people who set a 4 on how happy they are? And it's nice to know, I guess, but there's not really anything that you gain from this. You get a lot more by looking at means and standard deviations. There's a reason we do those, right? Because those are really important things. If you just looked at this, if you can figure out the mean just by looking at this for a half a second, then you don't need to be in this class. Generally speaking, mean standard deviations are going to tell us more than this chart. So these numbers aren't wrong, they're just not particularly helpful. All right, so now that we've seen frequencies and descriptive statistics, let's do our last one here, which is explore. Our last option that we're going to do is explore. So in this case, what we have is a much more, well, at least somewhat more complicated box, and this takes a little bit of explaining. So in SPSS and other programs, other kind of statistical lingo, nominal variables are sometimes factors. which is just the category you want to look at things by. So what Explore does is it allows you to look at descriptive statistics for your variables based on different factors. So for example, you get means and standard deviations of happiness for different genders. So let's just start off and hit that. And you can see in the Explore, we have females are 0, males are 1, and we can get means, confidence intervals, medians, everything for females, and then it'll give us males, which gives us just a lot more information than the straight up descriptives does, and it allows us to see by gender as well, which is, to me, a pretty nice thing to have happen. And it also adds stem and leaf plots, which are a lot like what we saw, please pardon me, up here with this table, where you saw how often they occurred. But the stem and leaf plots do this by the frequency by gender in this case. And we'll also give you these plots. Those are not very meaningful to us now. We're not going to get into much here. So let's do political affiliation here. Hit OK, and up it will come. We have 0s, 1s, and 2s for our different political affiliations. We have liberals, the information, independents, and conservatives, and these stem and leaf plots as we saw previously. So that's all we really need to do for descriptive statistics. So right now, what you will need to be able to do, everything from the Intro to SPSS PowerPoint from before, you need to be able to run frequencies, descriptive statistics, and the Explore function. And you will have an assignment based on this lecture, as you will have with all SPSS stuff, so make sure you check that out on Canvas.